looking at industry auto components, we've got, you and I have this beautiful opportunity to have handmade, like bread from flour, started components from scratch, point to point, perfectly made, no boards, no extra help, nothing ordered in. That's wonderful. And it offers us a bunch of open doors at prices previously unheard of. So for small, inexpensive $1,000, $1,500 amplifiers, we can do things that $10,000 amplifiers can't do. And there's reasons for that. And I was looking at the industry, and there's, basically Ohm's law, power supplies. They consist of two main factors, voltage and current, right? So, for instance, if you take a look at large amplifiers that are 250, 500 watts, they usually run at 100-volt rails. So their transformer has 100 volts. And a transformer's voltage, the higher it is, it's basically it's like turning up the volume. So if you got an output transistor that you bought, and you're going to use that and hook it up and connect it to some output speaker terminals, and you use your transformer and you power these output transistors like you do on any amplifier, you would have a lot of wattage. So if you had a transistor that does 50 watts at 50 volts, when you turn it up to 100 volts, it gets up to like 100, 150 watts. And they play that game where you want more wattage. And the reason is, historically, with inexpensive industry-made gear or production line-made gear, you had to have very high voltage rails or very high voltage in your transformer so that the outputs, which are on a heat sink at the bottom, I'm just showing you a Cambridge component, for instance. And what this is doing is it uses this big transformer to make that wattage really, really loud. They can say, oh, this is 100 watts per side. But if they took this voltage, this one happens to be a little over 60, and they put it down to 35 volts, these outputs would now drop to about 40 watts. Excuse me. When you do that, you're changing your waveform or your sine. You're lowering the noise, because the higher this voltage is, you've gained, all the noise goes up with the voltage. So you're not as quiet. You have capacitors. This has extra capacitors in it. There's two main capacitors, two of these, two little ones that are in this amplifier originally. We added a $300 mod here, and we added 6 times the original capacitance. So for the folks at home, that was a bit of a little physics start, but a transformer running quietly is like a cup of water up high. So you have your output transistor, and as you raise voltage, you're putting your water cup, which is energy, up high, and you're dumping it when the music says to. And that's very, very fast. It gives you a lot of pressure. The problem is it doesn't sustain very long. 100-watt receivers or amplifiers that are very clean, same specifications, they all sound different. You'll see another line here I drew that's joined to this main line, and that's energy. This is capacitance.
Can you move that diagram?
Sure. So I made a little drawing of capacitance. So you got your main transformer's got the voltages, and the higher this goes, the higher we're raising the cup. So when we're dumping the cup, the water is coming down with a little more pressure. So we get more wattage. When we have our energy here, because we can't come out of the wall fast enough for the transformer to keep replenishing the water in this little tiny cup, which is a little tiny transistor, it just doesn't have enough juice. It's not very big. It's a little silicon transistor. We need capacitors connected to that line to fill in the energies, the holes in the music. And when this stops and runs out of energy, the music stops.
Also, are you saying that the capacitors are like reservoirs where you can store, instead of storing water for the cup, you're storing the energy for the music?
That's correct. That's correct. And we're depleting it quickly, and we're not making a light, so we don't need constant. We need to replenish the little difficulties in it.
And since there are a lot of capacitors in a good power supply, you don't run out of energy.
That's not as fast. You always run out of energy. There's no limits to how much we want. So I compared the And we've heard all this wonderful stuff from Angela-Gilbert Young and how good it is. And there's many reasons for it. But there's two basics. One is purity of hand contact. The other one is energy. And in the energy, typically the industry will have a little tiny kiddie pool. And that tiny kiddie pool is connected in there in a little tiny wire. And it's bringing in energy, 2 capacitors. Like I showed you before, there's 2, let's say 10,000 per side microfarad capacitors. They're the size of a C-cell battery. We added 6 of them to that one to make that kiddie pool into a hot tub.
Okay.
So we have more water.
Yeah.
When Gilbert builds his regular components and funkies and stuff, so we added in this one, we added 10, 20, 30, 40. We're in a 60,000 microfarads from a 10,000 per side start. When we went into this piece, which is a power supply from a company that's very famous in audio, they had 2 10,000 microfarads, and we added 20,000 more. Or sorry, 15,000 more per side, 30,000 more.
Well, it looks like there's a lot of room in there to add more.
Yeah, this is an open power supply. It's a flat cap, and it has 24-volt regulators. The little diodes in there, so we can't put too much of this in there because this transformer has to charge them, and we don't want to burn this up. That's the limits of the way this design was made. But we could move the needle on the sound very, very quickly and take this past what they sell as a high cap. This is a high cap's energy total, just there alone. So we have a high cap and flat cap now combined. It's a name piece. It's regulators, though. 24-volt regulators. The fact is, if this is 24 volts perfect, we don't need regulation. Regulation, it's like me sitting on a chair. Shows you a modification of something that exists. Also, you'll see a lot of testing done on capacitors in a line. And the lines on, you see, there's little tiny, you can't see them in here, but they're about this wide. And they're little pieces of copper coming off these that are 7,000ths of a millimeter, and they're sealed between fiberglass. So even if we put a pile of these in here, it still slowed it down 20 or 30%.
Would that
versus what we use.
Would that be like a garden hose that?
Oh, exactly.
Yeah, it chokes the water supply. It's not because the diameter isn't large enough to let the water through.
Well, that's right. There's 26 electrons per atom, and we all know from car audio you got to use wire to get the battery to charge the amplifier in a car. This is one of Gilbert's mods we just did today, which is crazy. This is 5 million, 5 farads, 5 million microfarads on 14.2 Romax lead soldered perfectly by hand with the best little connections I've ever seen. It's in air dielectric, so it's not sealed in fiberglass like thin 0.07 thousandths of metal. There's lots of metal for this stuff to move fast. We have 3 sections in this, and the capacitors are absolutely massive. It's like giving the energy of the sun to a three-way component, one for the filament of a tube, one for line stage, and then one for the output stage on 3 different conduits that go direct to our integrated amps. This is fabulous bleeding edge, but it shows you the difference between that. The component that I just showed you is worth $2,700, that little piece with the 2 little caps. This is $6,500, and you see the difference. It's 500 of these other ones. So that's what we do, and we do it in all our little guys as we go on. And this energy is the single most important thing in having the music fill in right, provided that the signal path has the potential. And I'll show you the potential as well, so the customers can learn a little bit.
We talked about that in our last video, where we talked about the business model and why other companies can't do this. Because
and we're not putting down any other companies. The companies are trying to do what they can.
They just have to do what they can do.
Right. But we have the gift of dealing with one lovely 40 or 35-year experienced everyday person that ran into this without regard for income. Some meager income was a residue of doing things right and make people happy and smile. We showed you this Cambridge audio. It's an SR10 older one. We do the new ones as well. They're great little pieces, and they're mid-fi, so they have, like you say, it went from the amount of water in a small kiddie pool, which is in most things, to half of a hot tub. And we made it a full hot tub here. What we want is a lake. because we're going to suck in more than a hot tub. Music really needs a lake. So the reason we only can go so far with this amplifier is, you see this signal line that's in here, these boards? That's all a printed board made by somebody. They stamp it in there and they connect it with little ribbon connectors all over the place. And each of these ribbon connectors is a soft press on, let go type device. It's not a hard connection. It's not sealed out by solder. It's not a heavy gauge. The parts are very tiny and there's little tiny gauges. So each part has a choke or a slowdown or a little reflection in it. And they amount to not great fidelity and elegant detail, as opposed to, so when we can only go so far out of MG here because we're going to overcome some mistakes. But there's mistakes in this board that are basically because of expense. They want to keep it down. They've got employees, millions of dollars, marketing budgets. They have to. The front of it also has a bunch of lights in it. This isn't a volume control, as you can see the back. It's an electronic little resistor volume control that's that goes with the little clicks. So it's not physical. And it means each little click needs a little resistor to run inside there and turn it up and down. Each one of those contacts the signal, and each one does some damage. A regular volume control that's a physical contact to a plate doesn't have those problems. And then you've got all the lights for switching inputs, little buttons we touch, changing input to input, and they're all up here, and there's tons of little connections. All of these front 200 to 300 connections in their logic circuits are all touching my left and my right signal line. That's not good because it's doing a little bit of damage. So we can make this sound pretty wonderful, but we can't ever get it near something that's handmade. There's no way you can do it. And
well, you'd be trying to compensate for damage that you can't fix.
That's correct. And linearity that we can't restore.
That's right.
So if we can't restore linearity, this is how a preamplifier is done perfectly. And you'll see from the side, Gilbert and I were looking at a couple of pieces of gear today that had 90-degree turns and some nice looking wire inside. And you could actually see the needle nose pliers where they turn the wire. Well, when you turn a wire like that and you've grabbed it and pinched it, you've changed the diameter of the copper inside and you've altered it with a kink. That won't matter if you're lighting a light, which, eventually the voltage and the ballast will match and the light will work. But in subtle music and tiny little things moving elegantly and up and down in electrons in music, you need to do it so no wires touch. You'll see through the middle side there, not a single wire touches. And not a single wire is crimped or bothered so that its diameter could be altered. So as things vector or flow, you get perfection point to point. You'll see each one's damped in silicone. You'll see lead and silver solder connections. And underneath, you'll see 47,000 microfarads in a line stage. That's unheard of. This isn't even in, it showed you a 100-watt amplifier with less capacitance than this. And this is just for signal. So all those little sensitive signal drive parts get the energy they need to be beautiful and full. And they don't slow down and they don't run out. Because if the energy stops in any way, the music stops with it. So that's why things can sound thin or not rich, not bassy, not right, not the timbre or texture or color or tone of the original recordings. And when you do stuff like this, they do.
Well, one of the things in our conversations that I've never mentioned or asked about before, does any of this relate to reliability? Does doing these things make these units any more or less reliable in the long term than not doing them?
Absolutely. If you take a look at this component, for instance, and there's logic circuits in it in the front. So logic circuits are in behind this board with the contacts, the displays, and all these little functions of you've got little tiny decision makers that say, when I press this, change inside and reroute the signal for me. When those little tiny things fail, if one of them fails on any one of these 5, this amplifier is done. You can't re-emulate the little chip in there to tell it to redo it right. You have to go in, reprogram it, or remove the chip and redo it. The amplifier is dead. This could all be good. Your amp could be good. Transformer could be good. Your line stage and capacitance could be wonderful. Everything fuses, works good. but one little tiny part on the decision making up front or the volume control, and she's dead in the water. And surround receivers are really typical of that, usually between 5 and 10 years. Something in their logic circuits, because they have the lights and the switches, will fail and the unit's dead.
Well, it kind of reminds me of the space shuttle, where the thing that brought it down was the 50-cent O-ring. I mean,
similar, but these have computer programming in them, and we all know how sensitive, your app is, and how many times you got to restart a phone because a small little voltage dropped on something, and it went, I'm done for right now. But with these components, they're so inexpensive, they can't restart themselves from zero. They try to reboot, but when they lock up, they're done. Now, if my switch is here, see the switch? There's my input. It can never break. It's a hard contact. It's like my finger touching here or touching there. And if I simply can move my finger over, I can always fix it. This isn't going to break. And if it ever did, I can still contact it directly. And I'd always have one working. It's never put to being useless. Right. If the volume control, if one of the resistors in the logic circuit for the volume control fails on the other one, you're done. This one is like a disc brake. It's a huge circle plate of carbon, and there's a finger on it, like your disc brakes going over that grab it. High voltage, low voltage, and anywhere in between. It's just a simple contact. There's nothing to break. It won't fail. It's physical, just like the old days. And everybody, that's played with the old components, you see they're still working. That's not true of today's fancy stuff.
That's why there's such a huge market for all the vintage stuff, because people know how that stuff was made.
We're actually, Angela-Gilbert and I spoke about that this morning, and we were saying some of the old, 70s Onkios and some of there's certain pieces of gear were really, really good. And if you add capacitance energy to them on modification like we do, and or you balance the transformer, put a step-down transformer on it to lower it, because in the receiver wars of the 70s, they tried for high wattage. Well, all you got to do is raise your voltage for that, which is raising your noise and making it not sound so good. We just did a mod on a Bryston 4B from the early 70s. And it runs at 100 volts. And Gilbert took all of the points, left, right, and center. So there's like 60 connections that were on plug-ons. That went from board to board back then. They were nice looking thick boards, but they were getting hot. The amplifier ran hot. You could almost cook an egg on it. It was great. Worked great. 250 RMS per channel. Big power. So he has this other transformer box he makes me. And I said, what's that? He said, well, you plug the 4V amplifier into this, and this transformer steps down the one that's inside of it. And he said, the Bryston had 2 transformers, he said, and I balanced them. I put them together. And I said, what's that do? He said, it's more legs under the table. He said, you got more stability in feet. He said, you lose from some separation a tiny bit, maybe 1%, but you're gaining all kinds of strength and all kinds of stability when things are drawing from that transformer. It's very strong on its feet. It's like a ballerina and a bull mixed. And I said, well, that's wonderful. And I said, why did you move the voltage from 100 watts down to or 100 volts down to 45 volts? I think it was on a step down. I said, doesn't that lower the power? And she said, yep, that lowers it from 250 side down to about 110, 120 side. But the sine wave that's 100, voltage is the height of the curve, right? And the sine wave when you're making the curve. You're looking at a scope. Well, now it's a little less than half. He said, that's less than half the noise. So all of a sudden the amplifier sounds midnight black, has elegance, like our $10,000 Gilbert amplifiers. And I said, that's all it is? He said, yes, they have to design it correctly for music. It's not about printing out that it does 250 RMS a side.
Well,
it's about getting music right.
Well, as we've talked before, that's the difference between marketing people getting involved and designers that actually know how to design an amp and then have someone build it correctly to execute their design.
Well, I got an answer from one of these things in terms of most industry stuff. Was talking about voltage currents, which is like Ohm's law. In terms of most industry designs, they're over-engineered. And most engineers want to show off their skill. And they make it more complicated than they need to. That's how some of this stuff happens. And the buttons look fancy and the lights look fancy and they like that. They want to impress customers. They want you to listen with your eyes. If you look at it, you like it. If you listen to it and you like it, that's secondary. It's about marketing in the first 10 minutes and getting you to buy the thing. So that's all bad. And at the end of this thing, the eye opening, it said there was a person that said that looked at the internal components, the layout, and make some judgment of sound. It's like they look at the component and, as best they can see it. If they see a large transformer that's shiny and covered right and has a nice logo and shiny looking or big looking heat sink and in a front face that's neat, they make a judgment on the sound. You can't do that. You haven't driven the car. It's like looking at a car and it's a shiny looking Ferrari, but inside there could be a 3-cylinder engine. And in audio, it's never been more true. The parts on the inside sum up the totality of its performance. There is no run resistance. There is no beauty involved, all that stuff. And it's a typical Ricky mistake, and companies take advantage of it in audio, giving you specs that say, okay, we're big wattage, or we turn it up a quarter, and it's so loud and it's unbelievable. I've had a lot of people say, well, I only have to turn that to a quarter and it's so loud. Do you realize that the linearity of a volume control in the first quarter is where it's at its worst? It is. Where it's at its cleanest and most linear is from there, about 2 o'clock or just under, all the way to the other side.
Well, that was one of the things when I worked retail that we had to explain to customers. They always seem to be more impressed. They go, wow, that's really loud. I only have it turned up to 9 o'clock and it's already blasting me out of the room. And we would say, well, that's great, but try turning it up a little more and you'll notice hardly any volume increase at all, because most of the volume increase was between 6 o'clock and 9 o'clock.
That's right. And that's the side of the amplifier, and you get impressed right
That's right.
The rest is clipping. And he wrote down the consistency of diameter of the wire, too. You've got bend points. We aren't even speaking of the ones where you've got those push-on terminals, and behind that, as we all know, every time you're bending, when Gilbert lays a wire right on top of a board and then lead solders it perfectly, just lays it in there. Doesn't solder bath it. Like the board thickness there's air, all the metal's exposed, so it can be quick, and it's thick, very thick. But you have to design your own stuff to do this. You can't just order a board. And unfortunately, in mass production, they've got to order things, and they got to have somebody make it that's doing huge production. And it hurts, and it changes the circuit. It has an effect because music's moving. It's not constant. Yes, the connection's functional, and you can measure that it has a good specification. That does not mean it'll play music, because you have to move it, and you can't measure a moving target. There's no scope that's going to measure music on the move. Now, some engineering will say, oh, you can just measure a component and that's good enough. Nothing could be farther from the truth. And they'll argue till they're blue in the face because they're using laws of physics and only math for an explanation. But that's a fixed point in time. Music is on the move. Energy is on the move. What counts, you can't necessarily measure. And you have to have a ton of experience. So it's been enlightening for me after 43 years of digging my own stuff apart, because I didn't have money for audio. I just want to make better. And finding out that we're all into an industry where we're getting taken advantage of a little bit because we don't have any knowledge, and the people that have a few terms we don't, we'll listen to them. Or if they're a journalist and they're writing, we'll listen to them. And that's okay. It's not their fault. It's not the customer's fault.
Right. I don't think there's anything nefarious or malicious going on here.
No.
I just think that the manufacturers are doing what they have to do. They design things to meet a certain price point, and that's the end of it. That's the best that they think they can do to meet whatever that price point is, and that's it.
So at the end of the day, we're just lucky because we have somebody that hand makes by themselves.
Well, that's right. That's right. And we're not going to sell that stuff to everybody, because no matter how good we are or how good you are, certainly a lot better than I am, no matter how good we are at explaining these things, we're not going to convince everybody. So that's okay. No. That's why we have other things to sell. Right.
I've had so many customers that have been lifers in hi-fi between 60 and 80 years old, and then young people as well. They'll come through and buy a product, and they said, if people really knew what you were doing, Mike, there would be 500 outside your door every morning.
I for one, am surprised.
I said, I couldn't do it. I couldn't do it. but we'll have 15 years of fun, and whoever comes along, they end up like disciples, not customers, because they drag all their friends in by the ear. They say, "No, no, no, no! You know how much I wasted before I got here and got one of Gilbert's pieces?" I went, "I know, I get it." But these beautiful, perfect things. I mean, what did Einstein say? Make things simpler, but not simple. In other words, achieve this task that you want to do. Do what's necessary to create the circuit you need, but as simple as possible, least amount of parts as possible. That there's nothing more true than that. Every part does damage. Don't use more than you have to. That makes sense. And look what's in front of me. Don't use more than you have to. That gives you speed. It gives you life. It gives you energy. It gives you transient, left to right response. It's unbelievable what happens. The music glows. That's important. And I'm proud to be part of it. I know you are too. Everything we sell is like, it's like crack cocaine for those in audio. It's crazy.
It does, and it is, and that I think that's why we both have so many repeat customers.
Yeah. Yeah, we went over a lot of things. We're going to do soon we're going to come up with a path that shows, we're going to talk about ground path and how it affects sound soon. We're going to go deep into it about hum and buzz and find ways so people understand that we're going to find ground spots and how to do them at the lowest impedance possible. There's a video coming. Be happy to do that with you. I just wanted to show people, you know, that the industry is going high wattage, high specification, and they could double the performance of any product they make by just lowering the output the transformer voltage. And the thing will be quieter better.
That sounds good to me.
I know they won't do it. They won't do it because they're all fighting each other for this wattage game. The numbers, once the numbers get high enough, they can't stop, right? They did it in DACs, for instance. Like, remember the DAC thing that we went through the years, and they're going, first they'll go, you know, in retro gear, resistor to resistor in a DAC is the best DAC, not the best DAC. R2R was the original DAC design in the 80s. Now they're using it again, and I think the reason is they pooped out the upscaling DAC, which was where we were going, right? We were at 2496, 24192, then we went DSD 24732. Now they're running out of higher numbers, so they went back to R2R to reinvent the wheel to sell to us. And we'd already done it before. Like, the circuits that they're doing, that's proving to you it's marketing. They're selling you things, and they have to get you on a number to buy onto a spec because you can relate to that. It's almost like it's physical because it's printed.
Well, the way a lot of this stuff is going right now, companies are running out of ways to charge people. And we're seeing this, it doesn't relate directly, but we're seeing this right now in software, particularly something that relates to what we're doing right now is video editing software. Video editing software is already at the point of diminishing returns. The companies that write video software can't make money anymore because they don't know how to charge people because they can't add more features to justify the price. So what do they have to do? They have to figure out a new way to charge people. And that's becoming increasingly difficult. But what we have here with what the design of these products is, we have something that's really never been done before.
Oh, I mean, what we're doing with Angela-Gilbert, what Angela-Gilbert's doing.
That's correct.
We're just along for the ride, Walt.
That's right.
When you run into a Nikola Tesla that happens to be in type involved in audio, you consider yourself blessed, and I'm going to have 15 years of fun, then it's over. And he or she will be famous after she's long gone.
That's right. That's right.
And I'm having so much fun, having so many people smile and cry listening to music and being grateful. And it's not about money. Money's just a tiny residue of what goes on of doing something that's so much fun. It's like we're building racetracks.
Once again, we're up against the clock and running out of time. So I think we picked a good spot to end this particular video. And next week, we can probably pick it up with the next topic that's on your list.
That ground, we're going over it on a video.
We will hit the ground running. How's that?
There we go. Well said.
So thanks always.
Bye, everybody.
Time, and we'll see you later.